My talk is called Motion and React, and my name is Kaylie. I'm a front-end engineer at Eventbrite on the front-end platform team. That's me in motion. The funny story about this is that it was taken at the Color Factory, which was an event that we ticketed and also crashed our site. Not because it was crazy popular, but because one of our principal engineers wanted to try a new caching strategy. As it turns out, that's what principal engineers do. It was in Bendo. And I know this because I was trying to buy this ticket as well myself, dog fooding, obviously. So if this kind of edginess entices you, we're hiring. Come talk to 1 or 20 of us sitting out here in the front at the break. Cool. And here's a list of things I like. Love JavaScript, really like Node, CLIs, Bash. I mean, UI is there, so I definitely like it, but it's kind of not on the high on my list as much as I like sort of the front end, the back end of the front end kind of things. So sometimes, because of that, CSS makes me feel like this. And when I'm adding motion, I'm just gonna add some classes, looks good, ship it, right? But obviously, that's not the right way to do things. So I asked for backup, and that's Dave, our product designer on our team, and asked him, so why motion? Why even bother? And he had this pretty insightful comment that motion could provide affordance and usability by hinting at things like continuity or relationships between 2 different components on your page that might otherwise not be related. And it could also become something that your users could relate to. It provides delight and part of your brand personality. And it's also critical for mobile design where you might not have as much real estate and have to resort to gesture and animation to communicate with your users. And motion design has its roots in animation. So in the 1980s, the original animators of Disney published a book called The Illusion of Life, where they discussed 12 principles of animation. And one of them, for example, which they deemed the most important, is called squash and stretch. So it's this animation that gives the illusion of weight and flexibility to an otherwise inanimate object. And since then, we've come a far way where experts in the UX and UI field have applied these principles in the UX world, where we have things like zooming action, transitions, modals, and overlays. And I have links at the bottom of each slide, and I'll deploy this later so you guys can have access to that. So the next logical step was, OK, I get that this motion thing is going to become a thing. So how do I start implementing it in my projects? And the internet, in its infinite wisdom, had all these different options, right? CSS transitions, animations, web APIs, all the different libraries, which I'm going to share with you today. So get ready. The first group I'm going to talk about are CSS and friends. And we know some friends are better than others. Similarly, not all CSS properties are equal. Some of you might be familiar with this rendering pipeline, where at first JavaScript gets executed, and then your browser figures out what styles to apply to each element, and then figures out how to lay out those elements, and then actually fills in the pixels with different colors, and then finally does the composite step, which determines the order of elements on your page. And this composite step, in modern browsers like Chrome, are interesting because it happens on a separate thread from separate compositor, asynchronous thread versus the main thread. So there are these good CSS properties like opacity and transform that only trigger the composite step and doesn't require you to go through all the previous sequences of the rendering pipeline. Versus there are not so cheap CSS properties, and they usually change the geometric attributes of your elements, so things like width and height and positioning, And you can read more about this later in CSS Triggers, which is a wonderful website that tells you across browsers how different CSS properties affect your layout. So CSS transition is like the simplest one you could start implementing. It has a declarative API. Most front-end devs are familiar with it. You have access to pseudo selectors, meaning if I hover over this, it'll apply that hover states class. And then you also get freebies like timing, easing, and duration, and it could also interact with other parts of CSS features like media queries or resolution if you want to modify your animations based on that. And because for transition, you're telling the browser you want something to move from point A to point B, the browser just kind of magically figures it out the best, most performant way to do it. And you get compatibility as well because it's a feature that's been around a lot. Next is CSS animation. You basically get everything from CSS transition, but it's also super powered with the keyframe API, which gives you a fine-grained control over how you want each slice of your animation from 0 to 100%, how you want it to exactly look like. And you can also do infinite loops, so these are great for things like loading states. So CSS seems pretty great, right? Like, when do we actually need JS? If you went to Joe's talk yesterday in CSS and JS, you might be familiar with these concepts, but some of the people might argue that it's really a problem about separation of concerns, right? If you think of CSS as the presentation layer and JavaScript handling behavior, animation kind of falls in the latter. And JavaScript community has also solved a lot of problems regarding modularity and portability and testability. And Disney knows this because they're using the same animation from Beauty and the Beast and Sleeping Beauty. So if you already buy into this framework, there's already existing libraries that could do this for you, right? Styled components, glamorous, emotion, they all expose the keyframes API that you could wrap along with your component, and you could start using this now. But if you still are not convinced, and you still love CSS because CSS is great, right? When do you actually really need JS? That's when you want complex interactions across user behavior, multiple components, and data sources. And JavaScript is especially equipped well to do this because A, it has state management across different facets of your application, and B, it has the event loop, which reacts to your user behavior and can decide for you when to actually execute something. So some examples in real life might be a notification component that changes based on the form state of success and failure. You might have complex data visualizations that animate differently based on data that returned from backend. And you also might want to do some cool user behavior interactions like parallax effect, or anything that really requires you to track mouse or touch movements like carousels, page turning, snap to grid, drag and drop. Or you might even take it a step further and want to get into things like storytelling and game development, which JavaScript could amazingly do for you. So we're going to use JS for animation. And it's good because we wanted to get here anyways. So the first thing about using animation in JavaScript is that set timeout is an anti-pattern. And if you don't believe me, you know when you like think about something and then someone smarter than you on Twitter tweets it out and you're like, yes, I'm not insane. That happened to me a week ago when Sebastian, who's on the React core team, tweeted that set timeout in animation is an anti-pattern because it isn't synchronized with frame boundaries. So what does that actually mean? You might remember the render pipeline from a few slides ago. It's basically if you have something that triggers an animation, you want 60 of these frames per second so that user doesn't notice any weird janks or flickering motion, right? And this process of rendering happens on the main thread versus set timeout, which kind of like waits here by like the task queue and has no idea what's going on in the main thread. So as you're recursing through set timeout and calling it, it moves on and asks the main thread like, hey, like you should like execute me because not execute. You should call this function because it's time. And then the main thread would be like, dude, I just gave you a layout. And set timeout would be like, I don't care, it's time, we gotta go. So versus request animation frame, which is the alternate approach, it's much politer, and as the main thread is executing, request animation frame, or ref, would be like, okay, I know JavaScript is happening here, and style and layout is happening here, so I'm just gonna insert myself here. And every time you call request animation frame inside of another request animation frame, it's guaranteed to be executed in the same spot, but in the next frame. So request animation frame is sort of the new way to do animation in JavaScript. And with React 16, it's a hard environment requirement. So if you look at the code here, you'll notice that it actually doesn't take a delay as a parameter. And that's because the browser will magically figure out for you what the best refresh rate is. So previously, you might have to resort to something like 1,000 divided by 60 for 60 frames per second. But instead, request animation frame relies on browser to determine whatever is the best rate. And this also means that in modern browsers, when you're running your animations in an inactive tab, then it'll slow down the animation and save your user's battery and CPU usage. And ultimately, it avoids what's known as reflow or layout thrashing. There are also a lot more exciting things coming on in this space. First one is web animations, and this is a way to natively implement animations using vanilla JavaScript. And this animation is like working right now because I'm using Chrome. And you basically have the same access to the API that powers CSS animations, but you do it with JavaScript. And it's a lot more intentional that way. An extension of that is another really exciting project called HOUDINI, which is a cross-organizational effort across people at Google and Mozilla and Apple to come up with an API to expose the underlying CSS engine. So just like how Babel propelled the JavaScript community forward by allowing you to polyfill new features, this HOUDINI draft is kind of equipped to do the same thing, where you would be able to define your own CSS properties. So I think these are really exciting. They're still experimental, but very exciting to see what would happen in the future. But for implementing stuff now, we want to get back to ref and make sure that we're using libraries that are taking advantage of ref, right? So this is also kind of already a solved problem with libraries like GSAP or Anime.js. And if you want to get really complex, you could use something like 3JS to do your WebGL animations. Or there's also an Airbnb library called Lottie that allows you to turn Adobe After Effects into SVG or WebGL-powered animations. And with that, let's make some tweens. That was a tween, but this is also a tween. So how you would hook it up to existing React component is you would pass it a ref, right, as a callback handler. And then you have access to the DOM element now. And I'm using Popmotion here. I like their API because it's more functional. You could actually compose and chain different animations. And you give it values that you want to apply it to. And yeah, and then the library just basically does a lot of whatever crazy animation or storytelling that you have to do. The pros of using these third-party libraries is that they're community tested, right? They have been around for a while, which means the maintainers and the authors have dealt with issues around browser compatibility and performance. The con of using these is that it requires DOM access, right? And as React developers, we feel a little icky about doing that. It's a similar problem that you run into when you're using like a charting library like D3. You have to allow these libraries to kind of hijack the DOM for you. And you also don't have access to the React lifecycle. One thing that's a very React-specific problem is that it's very hard to animate things as they're unmounting. And setting state as the component is unmounting is an anti-pattern. The React community came up with a solution to this, which is React Transition Group. And some of you might previously know this as React CSS Transition Group. But the API has like evolved slightly after that for the better. So there's like 3 main API that it exposes. The first one is transition, which is the lowest level API of them all. And you pass it an in-prob, which basically toggles the enter and exit states. So the transition component actually never unmounts unless you specifically tell it to unmount. Otherwise, it's just always toggling in between enter and exit states. And whatever child that you pass into it as a function will give you will pass you an argument that describes the current state. So that's one of these 4 transition styles, which is entering, entered, exited, exiting, or exited. And you might be thinking that could work really well with render props. Then you're right, because again, it's just whatever child that you pass in will just get this magical property, and you might have an object like this that called transition styles that apply these styles, and there you have a fully functioning React transition component. So the transition component also allows you access to pass in different functions as the component is entering and exiting. So if I click on this, it'll show it as entering and exiting, and you could pass in callback props and do the same for exited status as well. And if you're more familiar with the CSS transition syntax from the previous iteration of this library, then you basically do the same thing as a transition component, but instead of specifying the style that gets passed in as a JavaScript object, you have a separate style sheet that just has a class name, and CSS transition component will kind of magically figure out which styles to apply to your component. And if you don't want to do that, you could also just manually enter all of the class names for the different transition state. And finally, transition group is kind of the high-level grouping component that's pretty lightweight. All it does is orchestrate its children components, which has to be either a transition or a CSS transition component. And it'll just give it either enter or exit props and pass it down so that children components themselves could be responsible for how to animate, but transition group just kind of passes those triggers. So last thing I'm going to talk about is React Motion. React Transition Group does a lot of work for us, but Chang created this library where the underlying concept of it is to allow physics rather than timing to determine movement. And this is kind of like mind-blowing, but it actually makes sense, right? Because using CSS, you have access to a timing function like cubic Bezier curve, but that's only 2 different coordinates, right? Like it's only position over time. But with JavaScript, you get the scripting power. You could apply any algorithm you want. And the one that he picked is regarding spring motion, or in physics, Hooke's law, which basically says that there is a predictable relationship between the distance and then the force you apply to the spring and the stiffness, or like the attributes of that spring itself. So if you look at the code here, the React Motion component has like a reduced-like API where you give it like initial value called default style. And then the child that gets rendered gets passed the next style over from its previous iteration. And notice that I'm not passing in any timeout values because, again, it'll just magically figure out how it responds based on physics. That being said, there are configurable options. So stiffness is how stiff the spring is. Damping is the opposing force. And he has these 4 presets that you could use to describe this motion, like stiff or wobbly or gentle. And you'll notice that this motion is different from moving from point A to point B like the previous animations. It gives that lifelike squash and stretch quality that the animators were looking for initially. So I've noticed that like a lot of the talks are about choosing your own adventure, right? As software engineers, we want to make the right decisions based on the right context, use the right tool for the job. So if you're interested in sort of this fire and forget transition or animation that is unaware of its surroundings, then you might want to just work with CSS transition and animation because it'll probably give you the best, easiest performance. If you want more control, however, if you want to do complex animations across different components, different sources of data, and user interactions, you might want to start using JS libraries that were in the previous slide. But if you really want to be React compliant and think about how to componentize motion itself, then you have these React libraries available to you as well. It's on a spectrum of what kind of solution you're looking for. So that concludes my talk. Thanks. I'm Kaylie Alexa on Twitter. You can come talk to me afterwards. Yeah, you guys have been great. Thanks.